Okay, now let's talk about the Pythagorean theorem and its converse. Converse simply says, wow. The theorem says if I have a right triangle, then c squared equals a squared plus b squared. The converse says, wow, if I have three numbers and they satisfy the Pythagorean theorem, then they make a right triangle. It's the converse of it, okay? Understand the converse. So, what we've got is we've got some sets of three numbers, and we're going to see whether or not they satisfy Pythagorean theorem. Now, remember when I said what C represents? It always is the hypotenuse from the Pythagorean theorem. It's all, what it always represents. It's always the longest side, and it never touches the right angle. So, it's the longest side. So, which one of these is going to be C? The 50 is. So we're going to say 50 squared equals 30 squared plus 40 squared, and then we're going to do that, and we're going to see if it's true. 2500 equals 900 plus 1600. 2500 equals 900 equals 2500. Yes! That makes a right triangle. Now let's try these. Okay? Which one's C? Which one's your hypotenuse? Got it marked. It's easy to say. It's the biggest. Oh, it's 40. So 40 squared equals 20 squared plus 30 squared. Let's do it. 1600 equals 400 plus 900. 1600 equals 1300? I don't think so. No. Okay, this one says yes. Okay, now let's look at this one. This one's a little weird. They're fractions. Which one is the biggest number? Well, if you were to do the math, 3 divided by 7, 4 divided by 7, 5 divided by 7, you find out that 5 divided by 7 is bigger than any of the other two. Therefore, that must be the what? Hypotenuse. Now, when you square a fraction, you have to square the top and the bottom. So we're going to take 5/7 squared equals 3/7 squared plus 4/7 squared. 5/7 squared is 25 over 49. 3/7 squared is 9 over 49. 4/7 squared is 16 over 49. We add the tops and leave the bottoms alone when we're doing addition of fractions. They have to have the same denominator. These do. 25 49ths equals 25 49ths. Does that create a right triangle? Yes, it does. Why? Because those two fractions are congruent. They're equal. This one's a little weird. Square root of 5, square root of 12, square root of 13. Now, you would think that would create a right triangle because 5, 12, and 13 is Pythagorean triple. Second most popular Pythagorean triple. 13 squared equals 5 squared plus 12 squared. So does the square root of 13 equal the square root of 5 plus, we'll just put it together, square root of 13 squared. Does that equal the square root of 5 squared plus the square root of 12 squared? Well, let's see. Square root of 13 squared is, I think you'll find 13. Square root of 5 squared is 5. Square root of 12 squared is 13 equals 17. No, this does not work. Okay? Do the math any way you want to. Now let's look at this one. 9, 40, and 41. Which one's the biggest? 41, so that must be the hypotenuse. We're going to put it out front, make it C. 41 squared equals 9 squared plus 40 squared. 1681 equals 81 plus 1600. Well, I think when you look at that, you can see 1681 equals 1681. So this is a yes. Now, let's talk about Pythagorean triples real quick. Pythagorean triples. Are whole numbers. Whoops. Whole numbers that satisfy the Pythagorean theorem. Pythagorean triples have to be whole numbers and they satisfy the Pythagorean theorem. Well, is this a Pythagorean triple? They're whole numbers and they satisfy the Pythagorean theorem. Yes. Triple. Look at this one. Is this a Pythagorean triple? They're whole numbers. Do they satisfy the Pythagorean theorem? No. No triple. Why? Because they don't do it. Is this a Pythagorean triple? Are they whole numbers? No, they're not whole numbers. So no triple. Why? Because they're not whole numbers. They have to be whole numbers, not wholes numbers. Okay? But no, why? They're not whole numbers and they don't satisfy. No triple. Okay? This one, they're whole numbers, so they satisfy that. Do they satisfy Pythagorean theorem? Yes. This is a triple. Okay? So what we've done, we looked at, this is the converse. What we're looking at here is, do I have three links that will satisfy Pythagorean theorem? Yes. To be a Pythagorean triple, they also have to have whole numbers. Does this satisfy Pythagorean theorem? Yes. Are they whole numbers? Yes. Does this satisfy Pythagorean theorem? No, then they cannot be a triple. Does this satisfy Pythagorean theorem? Yes. Are they whole numbers? No, because they are not whole numbers. Does this satisfy Pythagorean theorem? No, then they cannot be a triple because they do not satisfy the theorem. Does this satisfy Pythagorean theorem? Yes. Are they whole numbers? Yes, they are triples. Okay. That's Pythagorean theorem.